Hi everybody. Today I'd like to show you about parallel lines and the kind of equations we could get for them. And some of those could be quadratic equations. I have a couple examples I'd like to show you. You'd like to make a sketch like this one. So pause the video, make such a sketch. We'll figure out what kind of angles we got and what kind of equation we should write. So you go ahead and pause it and I'll go ahead and get this done. I'm looking at angle 2 and angle 4. I won't even worry about the 2x squared minus 8 and the 15x. I won't worry about these two expressions until I figure out what relationship angle 2 and angle 4 have. Angle 2, this obtuse angle. Angle 4, another obtuse angle. Those are actually alternating exterior angles. I'm sure that angle 2 would be congruent to this angle. Those are vertical angles. And this angle would be congruent to angle 4 because they're corresponding angles. So I know that 2 and 4 are going to be congruent as well. So since I know that these are congruent, actually I should say that angle 2 and angle 4 are alternate exterior angles. And I know that alternate exterior angles should be congruent. So that means that 2x squared minus 8 is equal to 15x. Now it takes a little skill to solve a quadratic equation, but we're going to get a chance to practice it. I tell you, that's one thing that makes this class different from a general class. That's why we get to call this a pre-AP class, because we're going to use quadratics and not everybody else does. Anytime you ever solve any quadratic equation, you'll always set it equal to 0 first. That means I'm going to probably bring that 15x to the left-hand side, and it'll then be 2x squared. Put these in descending powers of the variable, so minus 15x. And then that negative 8 equals 0. We're going to use that fundamental theorem of algebra that says if the product of two factors is equal to 0, then one of those two factors must be 0. As we set out to factor this thing. And I got to find the factors of 2x squared. They'll fall here and here. And that's got to be 2x and 1x. I'm not sure which one, where they should go, but we can set it like this and we'll work it out. And then I need to find the factors of 8. They'll fall here and here. Could be 4 and 2, could be 8 and 1. But since I have that 15 in the middle, that's a big player. I realized to get to that 15, I'm going to have to put the 8 over here and a 1 over here. And then when I multiply these, I'll get 16x. And here I have a 1x. Actually, since I know that this 1 times this 8 gives me a negative 8, so one of them has to be negative. Because that 15 is negative, I think I would like this product to be negative as well. That way I get a negative 16x, put a plus sign here, and a positive 1x. That gives me that negative 15x in the middle. But whenever you factor anything, you should always go back and check to see that the product will be the same as the quadratic you had before. So first term times first term, 2x squared, outside terms negative 16x, but the inside term's a positive 1. That gives us the negative 15x, last times last to negative 8. So we factored it well. But if the product of two factors is equal to 0, one of those factors must be 0. So we should set 2x plus 1 equal to 0, and x minus 8 equals 0. From this case, if I bring the 1 to the other side and divide both sides by 2, I'll be convinced that x is equal to negative 1/2. That might be a valid root, but it makes me wonder, because 15 times a negative 1/2 would be negative 7.5. And if I did 2 times negative a half squared would be a fourth, and 2 times a fourth would be a half. Take away 8, and that'd also be negative 7.5. They would be equal, but I deny a negative angle, so I'm going to deny that root. From this function, from this factor, I find that x is equal to 8. I think that's our principal root. I'm supposed to find out some measures of some angles. Let's check on angle 2 first thing. Since x is equal to 8, 2 times 8 squared would be 2 times 64. That's 128 minus 8. So angle 2 would be 120. Now, angle 4 should be the same amount, because angle 2 and angle 4 were alternate exterior angles. And if x is truly 8, and 15 times 8, yeah, that's 120. That's just not one of the angles I'm asked about. I'm asked about angle 3, though. So I got to figure out how I can get to angle 3. And angle 2 would match with this angle. I know that angle 2 and this angle are corresponding angles. And those two are supplementary. So I'm thinking that 3 and 2 would also be supplementary. And the supplement of 120 would have to be 60 degrees. There's other ways you could figure that out, I'm sure. And then angle 5, I got to figure out about angle 5. But you see that angle 5 and angle 3 are vertical angles. And vertical angles are always congruent, so angle 5 must be a 60-degree angle. Now, sometimes this negative root could work, and sometimes both roots work. You'd be careful about that and check them both. But here, since this negative 1/2 gave me a negative angle here when I multiplied them, I deny it there. But if it worked, if it had given me positive angle measures, I'm happy for a negative value of x. Let's look at another couple of angles, please. New setup here. I still have parallel lines. And this talks about angle 2 and angle 6. Angle 2 and angle 6. It's pretty obvious to me that angle 2 is bigger than 90. That's obtuse. And angle 6 is less than 90. That's acute. So those angles are not going to be congruent with one another. But what kind of angle type are they? They're same side exterior angles. They're on the same side of the transversal. Same side. And what makes them exterior? They're not between the parallel lines, they're outside it. Same side exterior angles. And I'm going to abbreviate that. And I know that angle 2 and angle 6 should be supplementary. So I'm going to write out that these two things add up to 180 degrees. X squared, please be kind of quiet. X squared plus 3x plus 35 plus 10x plus 5 should add up to 180. Now we got a big fat quadratic equation right here. What we need to do first is clean up the left-hand member. Let's collect like terms. That would be x squared. And if I put this 3x together with that 10x, that'd be 13x. This positive 35 and that positive 5, that's going to give me 40. So we've cleaned up the left-hand member, and it equals to 180. But this quadratic, like every other quadratic you'll ever do, you're going to set it equal to 0 before you do anything else. And so to do that, we're going to subtract 180 from both sides, leaving me with x squared plus 13x minus 140. 40 take away that 180, minus 140 equals 0. Now I've got to set out a way to factor this thing. Give you a minute to think it through too. I know the factors of x squared are going to fall here and here. That's got to be x and x. Now I'm looking for the factors of 140. A couple things could happen to give you 140. Could be 14 times 10. What else could it be? It could be 5 times 28. 5 times 28 is 140. You got to sort through those and see what you think. Other factors of 140 could have been 7 and 20. I think the 7 and the 20 what's going to work right here because I can get that 13 from them. As I seek the factors of 140, I sort through all the things that are possibilities. Look for more if I need them. But with a 7 and the 20, I'm going to put a 7 here and a 20 there. Good looking factors of 140, but I know that this number times this number gets me a negative 140. So one of those has to be negative. Since the 13 is positive, I think the larger product, when I multiply these, should be positive. And the smaller product, the 7x, should be negative. And if we check out that multiplication, we got x squared, which we needed, plus 20x minus 7x, there's the 13x we wanted. Last times last, a negative 140. So this is the proper factorization. Let's set those factors equal to 0. So x minus 7 could equal to 0, or perhaps x plus 20 is. From the first case, I'd say, well, x, from this case, if x minus 7 is equal to 0, x must equal to 7. And from this case, if I subtract 20 from both sides, x would equal to negative 20. Now that might be an erroneous root, I do not know. But 10 times a negative 20, that's negative 200 plus 5, they've been negative 195 degrees. Yeah, we got this erroneous root right there. I promise you, sometimes a negative value of x gives me a positive angle measure. Didn't in this case. So our principal root is x equal to 7. Bearing that thought in mind, I'm going to figure out a couple of angles. If x is equal to 7, 7 squared would be 49, plus 3 times 7 would be 21, plus 35. And 49 and 21, there's 70 plus 35. I think that's 105 degrees. So I think angle 2 should be 105 degrees. But because I make mistakes, I should check a couple other things. I'm going to let x continue to equal to 7. And here I go 10 times 7 for angle 6. 10 times 7 would be 70 plus 5. That'd be 75. Let's check on that. Angle 2 being 105. Angle 6 being 75. Yeah, that works, doesn't it? Those angles add up to 180, the 105 and 75, so I think we're doing the right thing. Now I just got to find out about angle 6 first. Now angle 6, how does angle 6 react with angle, do I know about, what other angles do I know about here? Well, we know that angle 6 is 75. But what about angle 3? Well, angle 6 and angle 3, yeah, those are corresponding angles. They've got to be congruent. So angle 3's got to be 75 degrees also. Then I asked about angle 4. Now angle 3 and angle 4, they're supplementary because they make a linear pair together. And the supplement of 75 would be 105 degrees. I think that all checks out pretty good. There's another thing I want to show you. Just talking about these parallel lines. And these ideas about when lines are parallel, then certain angles are congruent, actually those are all biconditionals. We ought to get around to proving those, but if the lines are parallel, the angles are going to be congruent. But also, if the angles are congruent, then we're going to have some parallel lines as well. We're going to see instances of those right away. You should make a sketch like this one, and then I'm going to tell you about it. So pause the video, make a sketch that looks like that one, and let's talk about it. I'm going to jump right in. I'm going to think, for the first case, pay attention to lines A, B, and C, D. I might augment those. A, B being this line, and C, D being this one. So if I'm paying attention to those lines, it asks me to talk about alternate interior angles. And if these lines are parallel, are there alternate interior angles I could talk about? I would have to know which transversal it works with, and if I thought of this transversal, angle 3 would be an alternate interior angle with the one here, but that's not numbered, so I can't really use that choice. But if I use this transversal between A, B, and C, D, if I use this transversal, angle 2 and angle 5 are alternate interior angles. And they would be congruent. I started to write congruent right there, but they just want to name the angles. I would tell you angle 2 and angle 5 are alternate interior angles. In the next case, we want to talk about BC, this line, being parallel with ED, this line. So bear that thought in mind, and we're going to look for corresponding angles. Corresponding angles between line ED and BC. First, I'd have to find a transversal to work with. I think it's going to have to be transversal AE. Transversal AE does cross line ED and BC, and angle 8 and angle 4 are a good example of corresponding angles. I'll make that note right there. Now, you might want to pause the video and get a look at those and see if you agree with me, but I'm sticking with it. I'm thinking it's true. Next, I'm going to look at another pair of parallels. This time it's AB being parallel with CD again, but it asks me about same side interior angles. You really got to look for that transversal every time. If I use this as a transversal, I couldn't really do a pair of same side interior angles. It'd be angle 2 and this full angle here, but I can't name that full angle. So I'm going to use a different transversal. And I could name a pair of same side interior angles there. Angle 3 and who's the same side interior part with angle 3? As you think about this line being parallel to this line, cut with this transversal, I'd have to name this large angle right there. And I can't name that 4 plus 5. I can't do that. I got to call that angle ACD or DCA. I'm going to call that angle ACD. Yeah, I'm telling you that angle 3 and this angle ACD are same side interior angles. A couple of lines caught with a transversal like this, and I would tell you that this angle and that angle are same side interiors. And that's pretty much what angle 3 and this large angle ACD do. Now, watch this. I say, what lines are parallel and why do you think so? If we knew that angle 5 was congruent to angle 7, what would that imply? So I'm going to look at angle 5 and angle 7. That's this angle 5 right there. Imagine that it's congruent to this angle at 7. And I look for a transversal, a line that holds both of those. And here's the transversal I'm going to work with. And you see when you look at that transversal, the size of angle 7 tells me how this line would run. The size of angle 5 tells me how this line would run. So I'm thinking when angle 5 and angle 7 are the same, these lines would run side by side, never intersecting. So that tells me that it would be BC, or CB, you could say it that way. BC would be parallel to ED. to talk about what kind of angles I'm using there. And 5 and 7 are alternate interior angles. Let's make that note. Same kind of thing. So I'm going to tell you about a pair of congruent angles. You got to tell me what lines would have to be parallel. And the question is here, 8 and 4. So let's look at angle 8 here and say that it's congruent to the angle at 4 there. And the first thing you want to do every time is look for a transversal, a line that holds angle 8 and angle 4. That's got to be this line AE. And when I think about this line AE, the size of angle 8 tells me how this line would run, and the size of angle 4 tells me how this line would run. And I'm thinking if those two angles are congruent, they're corresponding angles, that would make these two lines be parallel. So here I would say BC is again parallel with ED. Why do you think so, mister? What kind of angles were 8 and 4? I'm looking at that again, this angle at 8, this angle at 4. Yeah, those are corresponding angles. And once you get those angle types, then we can do some kind of more interesting thoughts with them. Here's one more set. Angle 3 and angle ACD. So let me get to that picture. I'll pay attention to the angle at 3 and angle ACD. That's this large angle right there. And if those two angles are supplementary, they're not supposed to be congruent. I'm thinking, well, what lines would be parallel? And here's the transversal they'll work from. This line holds both of those angles. And this pair of angles is going to guarantee to me that AB and CD are parallel, if that pair of same-side interior angles are supplementary. They are same-side interior angles. Angle 3 and angle ACD, and they would force AB to be parallel to CD. I'm going to give you a little workout to do something like this, and you're going to turn it in on canvas with a real clear picture, and I'm proud of you. Thank you.